Okay, so we have a brand new unit here in geometry, and it looks like we've got some lava that's under a mouse and a carafe. Can't believe that's what we're really going to study. Oh, this makes much more sense. There's a mouse and a radar and a calf and an avenue. No, that can't be right. Okay, so what are we going to really study? Aha, surface area and volume. So we have been looking at perimeter and area, or in the case of a circle, circumference and area. And so we've been working with two-dimensional objects. When we go to three-dimensional objects, we could look at the actual outside of the object, that'd be the surface, and we find the area of that surface. Or we could figure out like how much space that object takes up, in which case we're looking at the volume. So we'll look at three-dimensional objects, surface area, and volume. Well, first things first, let's make sure we can classify solids. So before we go looking for surface area, before we go looking for volume, let's make sure we know our vocabulary. We know what names to call these creatures. So we're going to call a three-dimensional object a solid. All right, so basically it's got to have a bunch of sides. The sides might be, squares or rectangles. Right, most commonly we think of like a shoebox or cardboard box. Although there could be curved surfaces also. Think about a basketball, baseball, or like a can of soup, right? You got a circle on top, circle on the bottom, but then the rest of it is kind of a curved face. Polyhedron. Right? Every side on a polyhedron is going to be a polygon. So again, I think of like a shoebox or a cardboard box. Of course, we got each side, which we'll call a face. The faces meet at an edge. That's kind of like a line segment. And then for the corners, we call each of those a vertex. All right, and so you can take a look at the diagram, say, okay, each side is a face. The faces meet at an edge. And then where the edges meet, you've got a vertex. Okay, so polyhedra, which you just met, again, every side is going to be a polygon. Prism is one type of polyhedra. Pyramid, another type of polyhedra. And then if it's not a polyhedra, at least one of the sides is not going to be a polygon. So we could have a cylinder. Think about like a can of soup, a cone, a sphere. So to qualify as a prism, notice the bases have to be parallel. And so in this example, we call this a pentagonal prism because the bases are pentagons and they are parallel to each other. And then, of course, in the case of a pyramid, there's only one base. All right, so prism, you think about the top and the bottom as bases, they gotta be parallel to each other. Pyramid, only one base, goes up to a point. Well, looks like we've got some goofy animation. Something's out of order, but we'll live with it. So what should have been our first example here? Is it a polyhedron? Oh, yes it is. What kind? Looks like the bases are rectangles, so it's a rectangular prism. Is it a polyhedron? Yes, it is. Each side is a polygon. Most of the sides are triangles. However, we're going to name it from the base. And it looks like the base has 6 sides, so it's a hexagonal pyramid. Is it a polyhedron? No. It's a nice looking cone, but it's not a polyhedron because not every side is a polygon. Okay, it looks like the base is marked with a 90-degree corner and congruent sides, so we know the base is a square. So it's a square pyramid. No, it is not polyhedron. And then the one that should have remained as a mystery to the very end that showed up early. Yes, it's a polyhedron. The bases are triangles, so we'll call it a triangular prism. Relatively short lesson today. Big key is going to be trying to make sure we understand our vocabulary and what every part of a three-dimensional figure is.